All right, so let's take a look at this confirming zeros using the remainder theorem. The remainder theorem is another way that we can evaluate functions. If you want to, you could plug in -5 in for x and do all of this arithmetic, or we can use synthetic division. So if I have -5, and the first thing in synthetic division, make sure that your exponents, make sure your polynomial is in standard form. 7, 6, 5, 4, 3. Now I'm missing an x squared, so I am going to add a 0 for x squared to have that 0 as a placeholder. And then I've got 3, 2, and then 1, and a constant term. So I've got 3, 12, -14, 7, 10. I'm going to insert a 0, and then 2 and 8. So rather than having to figure out what -5 to the 7th power is and add all of this, our remainder from the synthetic division will be our answer. So we bring the 3 down. If the number is below the line, it gets multiplied by the number in the box. And I'm trying not to make any silly arithmetic errors. So f evaluated at -5 is equal to -2 according to this theorem. Alright, so this next one is done in the same way. Let's check and see if we're in standard form and no missing terms. 6, 5, 4, 3, 2, 1, constant. So I don't have any missing terms here. I don't have to change the sign. Whatever I'm plugging into the function is what I use for the synthetic division. So then I just use the coefficients. And instead of plugging the 2 in and 2 to the 6th, the arithmetic for the synthetic division is generally much easier. I mean, I'm not even using a calculator. Now I almost multiply. I do want to make sure that I'm adding these. You know, you can't make arithmetic mistakes. So if I haven't, then I claim the f evaluated at 2, that if you substitute in 2 for x and do this arithmetic, that you'll get 7. Same direction, so let's do the same thing. Is it in standard form with no missing terms? 4, 3, 2, 1, constant. Let's take -8. Peel off the coefficients. The first number always comes straight down, then it gets any number that's below the line gets multiplied by this number that's in the box and written underneath the next value. And then you add. Now I am going to have to use a calculator here so that I don't make a silly mistake. So if I haven't made an arithmetic error, you could check to see if my answer is correct by substituting in -8 into this in for x and doing that arithmetic and seeing if you get -26. All right, let's same idea. um, 3, 2, 1, 0, so that the polynomial is in standard form with no missing terms. If I peel off the coefficients, and so f evaluated at -4 is equal to 0. I'm listening to Bob and Tom show as I'm doing these. Now notice that it's telling us to verify the f evaluated at 6 is 0. Remember, after the synthetic division, we're using that remainder right there to write our final answer. And this is just saying to make sure that 0 is down here as our remainder. So if I use 6 and 3, 2, 1, 0, this is in standard form with no missing powers. I've got 1, -8, 9, and 18. Now, if it's true that f evaluated at 6 is equal to 0, I should get a 0 right here. If I don't, then either they have lied or I have made a mistake in my arithmetic, because the theorem we know to be true. Let's pull this down. And I'm getting a 0 there. So f evaluated at 6 equals 0. Now remember, what that tells you, that the input is the x-coordinate, the output is the y. So this graph is passing through the point 6, 0. Well, hey, that's an x-intercept. You haven't gone up or down. You're on the x-axis. And like I say, we are calling these the zeros of the function because the output of the function is 0. So that is going to be huge in tomorrow and in future days, that we get this remainder of 0. I mean, that's going to be significant. It's important for you to understand this. All right, so let's do this again. Again, I'm using -7. Now let's check and see, is this in standard form? Because remember, we're on number 6 now. The first 5 may have been in standard form, and then all of a sudden we forget to check, and that's the one time they don't put it in standard form. 3, 2, 1, and the constant term, so it is. So we peel off the coefficients. The 2 comes down. And I'm getting a 0 like I expected. Now, did I read the directions on the previous one? I did not read the directions. So I need to go back, use the result to find. I have not been reading the directions. So here in number 3, all right, so here in number 4, I'm going back to number 4 because it says to use the result to factor. All right, so what does this mean if this is 0? It means that we can rewrite f of x. Sorry about that. And if -4 is a 0 the function, remember that in factored form we write it as x plus 4. Now, we're rewriting this x cubed. We're splitting it up into a product, and now the next product I can get from my synthetic division, that this 1 means 1x squared plus 2x, and then minus 1. And see, there's a 0 remainder, so I don't have to write anything else. Well, now I can find all of the factors, all of the zeros of this function. Now it just wants me to simply factor it this time completely, so it's not actually having me use the factors. So I've got x plus 4, and then this guy, we'll have to use the quadratic formula, won't we? All right, so here, let's just say that this will not factor, that if I were actually setting it equal to 0, I'd solve using the quadratic formula, but this trinomial does not factor into two binomials with integer values. All right. And here, see, I was still using the directions for 1, 2, and 3, and I didn't, sorry about that, I didn't read this. So this f of x, instead of writing x cubed minus 8x, we can factor this. Now, and we're not using an x method because it's got 4 terms. Instead, we're coming in, they've given us that this f evaluated 6 is equal to 0. So that means that x minus 6 is a factor of this. And now, using my result from synthetic division, I have x squared minus 2x minus 3. And this time I can factor that. X minus 6, x minus 3, x plus 1. And now I have factored that completely just using this remainder theorem and factor theorem. All right, so here's where I noticed when I looked up and said that I used the results to find all the factors, and I recognized that I hadn't read the directions, so sorry about that. All right, now that means that this function f of x can be factored, and see, with 4 terms there, and it doesn't factor by grouping, the only way that I know how to factor this now, they've given me this negative 7 equals 0, f at negative 7 equals 0. In factored form, that negative 7 is written as x plus 7. And now this is 2x squared plus 7x plus 6. And this is where the x method has its true advantages, because with a leading coefficient that's different than 1, it helps us to organize and not do so much trial and error. The middle term is 7x. The first term times the last term is at the top of our x. And now we're looking for two numbers that, when multiplied together, give us the 12x squared, but when added, give us this middle term. So then we can come in the form of a table and help us factor it the rest of the way. The first term and the last term we write along one diagonal of the table, and the two values from our x we write on the other diagonal of the table. Horizontally here, 4 and 6 are both even numbers. The 3 and 6 are both divisible by 3. 2 and 3 are prime with respect to each other, but they both have an x here. These are both even numbers and they have an x. So we have factored this completely. We've got x plus 7, and now we know that this is x plus 2 times 2x plus 3. So now, this time, rather than telling me that f at 3 is equal to 0, they're telling me that, just in words, that x minus 3 is a factor. So I'm still going to do synthetic division. I still have to make sure my polynomial is in standard form, 4, 3, 2, 1, and I don't have a constant, and I'll need that constant. So I'm going to take 3, which, see, I've changed the sign from x minus 3, and I've got 1 x to the 4th minus 3 x cubed minus 1 plus 3, just 3, positive 3, and a 0. Now, if this statement's true, I should get a 0 over here. The 1 comes down, and we get a 0 there. Alright, so this f of x, they told us that one factor was x minus 3. They gave us the first one. They helped us there. Now, since this started out x to the 4th, in my synthetic division, I've lost a degree, and this first one now is going to be x cubed. For synthetic division, you always lose a degree. So this is 1x cubed, and then 0x squared minus 1x, and then the rest is just, the 3, 2, 1, 0 in the remainder. So there's no constant, there's no remainder. So it wants us to factor it completely. We see here, let's write it without the 0. X minus 3, and we have x cubed minus x. Well, there's an x that's common to both of those terms. So I've got, let's factor an x out. And what's left in there is x squared minus 1. And hey, we can factor that because it's a difference of squares. So we've got f of x is x minus 3. I'm going to put that x out in front. And then factor this to x plus 1 times x minus 1. So there's my answer for that. Alright. So when it tells me that x plus 4 is a factor of this, that's telling me that that negative 4 is an x-intercept, that if you evaluate this function, if you plug in negative 4, you're going to get 0. But we don't want to plug in negative 4 and raise it to the 4th power. We want to use synthetic division. It's much easier, the arithmetic. And 5, 4, 3, 2, 1, constant. The polynomial's in standard form with no missing terms. So I've got 1, 4, negative 5, negative 20, 4, and 16. So we're getting that 0 that we expected. F of x is, we've got our factor of x plus 4. And since this started out as a 5th degree, down here I know is a 4th degree. So I've got 1x to the 4th. I don't have any x cubes. I do have an x squared. I don't have any x's. And here's my constant term. So this is quadratic in form. That since the degree of the first term here is 4 and the degree of the middle term is half of that, then you can apply your x method and you'll get, that x squared x squared minus 1 times x squared minus 4, because negative 1 times the negative 4 gives you a positive 4, but negative 1 and negative 4 add up to negative 5. And now, since we have a difference of squares, we can factor this to x plus 4, x plus 1, x minus 1, x plus 2, and x minus 2. So we have factored it completely. So they're telling us that x minus 2 is a factor of this. Now let's check and see, is this polynomial in standard form with no missing terms? 3, 2, 1, constant, so yes it is. This x minus 2 being a factor is telling us that the f evaluated at 2 is 0. That if we do our synthetic division with 2, we use our coefficient 6, 1, negative 31, 10. If in fact this is a true statement, then we should get a 0 down here as a remainder. So and we do. So that means that we can factor this f of x. But of course, we knew we could factor it when they told us that x minus 2 was a factor. And now this 6, 13, and negative 5 helps us. The original degree was 3. When you divide by the x minus 2, you lose a degree. So this is 6x squared. 6x squared minus 13x minus 5. Now we don't know if we're done. We need to check to see, can we factor that quadratic? And our technique for factoring quadratics that have a leading coefficient different than 1 is to use this x method. We've got negative 13x, that middle term, first term times the last term. And if two numbers that multiply together, negative 15x and positive 2x, negative times positive is negative, and they add up to negative 13. So now, if we continue in the form of a table, along one diagonal we put our first term and last term, and then the two values that were in our x method that we found. We look horizontally, and we don't have any common factors here. Here we have a negative 5. Here 3 and x are both common factors. Here these are both even numbers, and they both share an x. So that means that this f of x, we've got this x minus 2. Then we've got 3x plus 1 and 2x minus 5. So I hope that helps, and sorry about, this was my answer. I did not read the directions from problem 4 all the way to problem 7. So I did not complete the problems, but then I caught it and came back and did complete it. And I don't have time to really, normally, sometimes when I make mistakes like that, I just redo the video, but I really don't have time to do that, so this is going to happen. Now here it was just evaluating, here, this is where I was stopping, because the first 3 directions were just using that remainder theorem. Alright, so I hope that helps, and I'll talk to you later.